Good afternoon, buenas tardes from South Africa. Welcome to the malolactic fermentation session, which is presented by Anchor Oenology. I'm Maret from Stellenbosch University's Department of Viticulture and Oenology, and I will co-present with Alda Laram from Anchor, which obviously is going to deal with the practice side of things, being in industry, and I was tasked to transfer the latest knowledge that we have on malolactic fermentation. So what do we know about MLF in 2020? I think it's fair to say that previously on the left-hand side, Inoculation uni was the major organism that consumed malic acid to lactic acid, and that was the main purpose of MLF. But in the last 10 years, we've definitely grown in the knowledge we have, where we also have a new species that is used commercially, Lactobacillus plantarum, and the value adding of MLF is now related to how does it enhance your flavor and aroma profile of your wine. So in the presentation, I will look at the process of MLF, as well as how does the process and certain factors influence the aroma we can expect in the end. So if we place malolactic fermentation within the bigger science of wine microbiology, I think it's an exciting field where microbiomics or the technologies of genomics have opened up numerous opportunities to also look at MLF a bit differently. Microbiomics is the buzzword currently used in the field of wine microbiology, where everybody is trying to understand either the natural flora that they have in a specific terroir or for a specific cultivar. As you can see, there are numerous publications on this, and there's quite a few coming from Spain directly, looking at some of your autochthonous cultivars. But the major focus for the first 5 years in this field was mainly related to yeast and yeast microbiomes. So this has led to obviously the field of yeast and the usage of specifically non-Saccharomyces yeast, and the diversity that there is in a much different way than what we thought of 10 years ago. But the great thing is, if you can look at the right-hand side, the last two articles, people are now also starting to use this technology to look at the diversity of bacteria within the grapevine field or within spontaneous fermentations, and how we can use this knowledge to maybe look at novel species for the application in malolactic fermentation, the same route that the non-Saccharomyces and Saccharomyces yeast went after knowing this. And obviously the knowledge we gain, we can also use for selecting for specific characteristics, like the top article on the right-hand side, where they looked at specific enzymes and how this can be used to tailor the flavorome of a grape and wine complexity. So within this, obviously, as I say, there's a lot of novelty that we can maybe use in future to also assist the process of malolactic fermentation. So just to remind ourselves, what is the main aim of malolactic fermentation? Obviously, the first is still to de-acidify the wine or to increase pH, and this is especially important in your cooler climate regions where the palatability of a wine that is very harsh from an acid point of view needs to be tailored down to make it more palatable for the consumer. So that is still the major drive behind MLF from a winemaking point of view. By removing malic acid, which is preferred carbon source for many of the wine lactic acid bacteria, obviously creates microbial stability, especially in your warmer climate regions where you have higher pHs and the diversity of your natural lactic acid bacteria is higher. But the last 10 years, the major focus has been in the selection of bacteria that improves or enhances specific aromas and flavor profiles in wine. If we had to compare a non-MLF wine to an MLF wine, the typical descriptors that people will give is that the wines are normally more complex and better structured. And this is directly related to removal of the acidity or an improvement in the acidity of the wine. It's normally described as being more creamier and fuller from a palate point of view. And this is in many cases related to the ester ethyl lactate, which is a direct esterification product from MLF, as lactate is the final product. And then if you want to create a buttery style of wine connected to diacetyl, there are strains that produces definitely more of this compound than others. MLF in general also reduces vegetative aromas by the reduction of aldehydes and higher alcohols, which are mostly associated with this type of characteristic. And then they also produce additional esters over and above what the yeast produces to enhance the fruity notes of the wine. Or we can also say if there's a reduction in vegetative aromas, this will immediately enhance the fruitiness of the wine. So I think the current knowledge that we have and the contribution of MLF is focusing on what does it contain and attribute to the aroma and flavor profile of the wines. But the major struggle and where we still need to look at MLF is obviously there's a lot of factors that has an influence on the success of malolactic fermentation in a wine matrix. And those are the factors listed on the right-hand side: pH, sulfur dioxide, the temperature at which we conduct malolactic fermentation, the amount of ethanol in the wine. I think the one factor that many people do not take into consideration in many cases is the amount of malic acid in the wine, the interaction with the yeast. How important is that? Does the yeast influence the bacteria or the process or the production of aroma? Nutrients, we have different inoculation scenarios today. Apart from after alcoholic fermentation, people also do co-inoculation. What is the contribution? There's fungicides, phenolic acids in certain cultivars have been shown to be a big contributing factor to either being successful or not. And the complexity for these little bacteria that have to perform the process is that many of these factors are in one matrix. So that makes it not easy for a winemaker to ensure that they have a successful malolactic fermentation. In my presentation, I will give a few examples relating to pH, ethanol, the selection of your yeast strain, and also looking at the different inoculation scenarios. Some of the other factors will be dealt with Alda when she speaks about the best practices for successful MLF. So yeah, just to say that Inoculation uni was obviously the queen of MLF and still is. But until we realized that we can also co-inoculate for MLF, which is in a grape juice matrix, which makes the matrix very different, we realized that other lactic acid bacteria species have the ability to also participate in MLF if we do co-inoculation of wine. So today, basically, we have Inoculation uni that is still the best adapted to the wine matrix because it can tolerate the whole pH spectrum of wine. Certain strains have the ability to grow up to 16% of ethanol. Temperatures for both Inoculation and Plantarum, I think, it's fair to say that the winemaker has control over temperature, and that doesn't play the biggest factor in ensuring successful MLF. Plantarum is definitely not as sulfur tolerant as Inoculation uni, so one has to consider the sulfur regime that will be applied to your winemaking, taking this into consideration if you should select Lactobacillus plantarum. Unos can use some sugar, and obviously being heterofermentative, it will produce small amounts of acetic acid with lactic acid, and this will make a little increase in the volatile acidity of the wine. And obviously it's been shown that it enhances the aroma profile of the wine. So the biggest difference between Uni and Plantarum is, I think, the pH. Plantarum is very sensitive to pH, and most of the strains on the market has been selected, will grow at a pH of bigger than 3.5. There are one or two now that has on the market that is definitely more tolerant to lower pHs, but it's fair to say it doesn't tolerate the same amount and low amount of pH than Inoculation uni. Plantarum also survives ethanol. It doesn't grow, so that is why many of the Plantarum cultures on the market, if you inoculate, is normally at a higher cell density. And the biggest other difference is that Plantarum under wine conditions does not produce acetic acid from sugars, so obviously there is no potential of increase in volatile acidity should you co-inoculate into a grape juice which has high concentrations of sugars. And we've also seen that the genetic potential and the enzyme profile and functionality in wine is different compared to Inoculation uni. So how can we use these factors and flavor attributes of the two species from a winemaking point of view? So this was an experiment done in Chardonnay, and this is to showcase the impact of a yeast strain on MLF. It was co-inoculation, which should normally be an easier way of getting your MLF through because ethanol will not be a problem. The malic acid is relatively high, but not compared to some of your cooler climate Chardonnays that you'll get. pH 3.3 and a total acidity of 9.3. So we tested several bacteria. These are just examples. For example, in bacteria 1, we used 4 different yeast strains to pair with each bacteria that we tested. And you can see for bacteria 1, none of the yeast strains allowed the bacteria to completely finish MLF. And for bacteria 2, there was 1 yeast strain that complemented the functionality of the bacteria. And for yeast 4, you can see that MLF was completed, although in these conditions, you can also see it took quite a while. So the bottom line from this graph is that it is really important that you think about your yeast and bacteria combination that you will use from a winemaking point of view, because this can determine a successful or not successful MLF. So the 2 times of inoculation and what are their advantages or disadvantages or some risks associated with them. This is just the major 2 that I've highlighted because obviously my time from a presentation point of view is also not too long. So the standard, and I think still most practiced time of inoculation is after alcoholic fermentation. And the advantage of this is that you can really make and tailor the conditions specifically to control MLF, as you do not have to think about alcoholic fermentation or specific characteristics of the yeast as this process has finished. So, but the risk is, and I think this is where in the warmer climate regions we have a lot of problems with MLF, is the depletion of specific nutrients in the wine, and also the high alcohol levels in your warmer climate regions where alcohols of 15 and a half is not something that we do not get. But yeah, so alcohol and the concentration of alcohol is a big risk if it comes to after alcoholic fermentation, and there your selection of your bacterial strain is really crucial to ensure it can handle the amount of alcohol in the wine. And then simultaneous or co-inoculation, which the bacteria then enters the grape juice matrix. Obviously, there is no or very limited amounts of alcohol, and you bypass the impact of alcohol in this process. As the yeast is not used up all the nutrients, they are still available for the bacteria. And this means that the matrix is a bit easier for the bacteria to navigate and complete MLF. And then one of the big things I think that wineries are doing this, especially in your warmer climate regions with higher pH, a larger potential for microbial spoilage, is that the process is shortened and the wines can be stabilized sooner, where that period between alcoholic and MLF in your after alcoholic, when MLF starts, is a big risk period for wines to get spoiled by microbes. And one of the risks or questions that we always get is, what about the production of acetic acid, especially if you use Inococcus uni in co-inoculation? And I must say, I think it's really a limited amount of wines that have been problematic due to the production of large amounts of acetic acid by Inococcus uni when used in co-inoculation. I mean, theoretically, it's possible, but in practice, we have not seen that many cases where this is a problem. So the question is, when do you inoculate? Obviously, after alcoholic fermentation, the normal practice would be at around 5 degrees boiling or 5 grams per liter of sugar. And that's normally when the wines are pressed or racked from the yeast lees. Then you can make a decision, do I want to stay in tank, or do I transfer into barrel and then inoculate after the completion of alcoholic fermentation? So that's a decision that will determine on the style of wine that you want to produce. Co-inoculation, there's different advices by the companies who have starter cultures on the market. There are some that want to give plantarum a better chance and do not compete with the yeast, that even inoculate before the start of alcoholic fermentation. Some people will inoculate at the same time as the yeast, just to make sure they do not forget about this. And then most of the companies say 24 to 48 hours after yeast inoculation. And obviously this will depend on your speed of alcoholic fermentation, because in South Africa, in our red wines, some alcoholic fermentations can complete within 5 to 7 days. So at 48 hours, your alcohol levels might be higher than what you would have wanted it to for co-inoculation. The reason why this is advised is obviously the yeast produces acetaldehyde that will bind to the sulfur dioxide that makes the environment more favorable for the starter culture that you will inoculate. So if we look at the general impact of MLF on aroma, on the left-hand side is just the typical descriptive terms associated with MLF. And at the top on the right-hand side is just 2 examples. By just altering your inoculation scenario, you will change the profile of your wine. If you use co-inoculation, the wines, it was the same matrix, same bacteria, just 2 different times of inoculation. you can see that the co-inoculation yielded much more fruity characteristics in the wine, whereas in your sequential inoculation, you still had fruitiness, but obviously your buttery character came out much more prominent in this wine. So this is a tool that you can use as a winemaker to tailor your wine. Do you want a more buttery style of wine or more fruity? The bottom one is Chardonnay, which was done with either in tank or in barrel, and you can see that the wines in the barrel had much more of your oaky, vanilla, spicy characteristics, where the wines done in tank is definitely much more fruit driven. So this is another option that you have to think about when you have to decide how will you implement your MLF. So as I say, the impact of the wine yeast on the process of MLF can be divided into three groups. The yeasts in group 1 are the yeasts that normally have a negative or an impact on the bacteria. So you can see in these cases we had 3 different bacteria compared to a yeast. And you can see that some of the bacteria definitely had a longer lag phase before they started with MLF. Your yeast 2 are the ones that is more neutral towards the bacteria, so they coincide in harmony with each other and they both do what they need to do. And then you've got the yeasts in category 3, which is stimulatory towards MLF, which you can see really advances the speed of MLF. So our question was, apart from the impact on the process, how does this translate into aroma? So this is just one of the examples. This was done in Merlot with co-inoculation, and this is the total amount of esters. So the purple bar right on the right-hand side, control yeast, is the yeast only. So we can see that by inoculating with different bacteria, it contributed to the total ester level. But the interesting thing that you can see is where the 1 is a yeast from group 1, and that definitely inhibits the production of ester levels because it inhibits probably the completion of malolactic fermentation. And then the yeast from group 2, which coincide and has a neutral effect on each other, the amount is almost, I would say, half added. And then the category from yeast in group 3, you can see has an enormous impact by making the environment more accessible for the bacteria. It directly impacts on the amount of aroma compounds produced by the bacteria. So the strains and the description of the strains from different companies is also important. So this is just an example of Inococcus uni strains that we did in Pinotage. And you can see the A, V, O, and C is the 4 different Inococcus uni strains used. And the red is the before MLF, which is basically the alcoholic fermentation. So a cultivar like Pinotage is really reliant on the berry characteristic. And you can see that strain A really has excellent potential to enhance this characteristic, which is directly related to a gene that we know of now. And strain C, you can see, had more of your fruity characters, which produced more. The other 2 strains were somewhere in between. So you have to think about what is the typical aroma compounds that drives the cultivar aroma, and try and select your strain that will enhance these aromas in that specific character of the wine. So if we have to generalize, we saw that whenever we do MLF, esters are always increased in amount, so are the fatty acids. And these fatty acids obviously contribute to the final ester profile in the wine. Your higher alcohols and aldehydes, which are associated with your green or vegetative aromas, are always decreased. And the diacetyl or carbonyl compounds are really strain dependent. There was no clear tendency to say it's up or down. It really depends on the strain that you will select. So, and obviously the question was, does this translate into sensory? What will be in your glass? And the answer is yes. So the strain that produced the most diacetyl was described by the consumers as being the most lactic, buttery. The two strains that produced the most of your esters was described as more fruity, and the one strain was more towards the control side, which had less of your fruity and buttery characters and was described more green. So if we look at the impact of pH and ethanol, we chose basically two strains. The one you can see had a much higher pH resistance and also was more ethanol tolerant than the other strains. This was a study in collaboration with Geisenheim. So obviously in Germany, they chose Riesling as a typical cool climate cultivar. And in South Africa, we chose Chardonnay. We opted for 3 different pH levels, 2 ethanol levels, which simulate cool versus warm. And we used 4 different inoculation times to inoculate for malolactic fermentation. So this slide just shows you the difficulty between pH and ethanol, or the impact between the two and the interaction. The yellow is the Riesling and the purple is the Chardonnay, and this is just for one of the strains, but the tendency was more or less the same. So the percentage on top of the bars is the percentage of malic acid degradation, and you can see the most difficult of the conditions is if you have a low pH and a high ethanol, which yielded less than 50% completion of MLF, and that directly translates to the cell numbers. As you can see, it was far below what we need for a successful MLF. Low pH, if you have a moderate ethanol levels, like 12.5% in our case, you can see that the malic acid degradation was almost complete. So the most difficult for any strain is the condition of low pH and high ethanol. But the interesting part was the control right on the left of the graph and the black line. Even if you have partial MLF, you can see that there is a contribution of malolactic fermentation to the aroma profile of the wine. So if we have to summarize this, you can see from the right-hand side, the pH increases, that the wines at the low pH was more diethyl ester driven, had more fruity characters, where to the higher pH end in the wine, you had more of your acetate esters and banana characters. So as a winemaker, you have the ability to manipulate your pH or to make a decision when do you harvest your grapes. And a simple factor like pH can shift the profile of your wine completely. And so does ethanol. So at the 12.5% ethanol, the wines were more green, grassy. And the higher the ethanol, you went into more floral, soapy, apple characters. So obviously deciding what the sugar level is of harvest is important. So just this slide is on inoculation scenarios. So you can see between the scenarios. So at 24 hours, you can see that the 2 strains used in this inoculation experiment separated completely from each other, which means that strains, when co-inoculated, their genetic makeup plays a much bigger role, because they have access to many of the precursors needed to produce these aroma compounds. And as you move along the matrix, the yeast obviously uses many of these compounds, where you can see in sequential MLF, the strains and the separation is not visible anymore, because many of the compounds is not available anymore for the bacteria to diversify the wines and the styles that they can produce. And you can also see that there's a shift in the typical descriptors over the time of inoculation. So Plantarum versus Uni, one of the biggest things we've seen with Plantarum, and Alda will also highlight this in her section, is that beta-glucosidase activity is the enzyme that splits off the sugars from the monoterpenes and nor-isoprenoids. Plantarum's functionality seems to be more functional in wine conditions. And you can see, for example, geraniol with Plantarum. The other two bars, the red and the green, is Inococcus uni, that Plantarum almost produced double the amount of geraniol, which is typically associated with your rose characteristics. And beta-ionone, which is a nor-isoprenoid, you can see far exceeds the amount produced, which was almost nothing by Uni, and Plantarum's amount was much higher than this. So obviously, if you have cultivars that rely on these two compounds, Plantarum might be something to consider to produce more of these compounds in your final wine. So I think one of the biggest questions in 2020 that we have from an MLF point of view is, what about non-Saccharomyces yeast? Everybody is now also thinking about co-inoculating non-Saccharomyces with Saccharomyces into their wine. And the question we have is, what is the impact on malolactic fermentation and aroma? And there's quite a few studies that is coming out now. So I think in the next 5 years, we will know much more on the different non-Saccharomyces and their impact on MLF. But this is something that we cannot just ignore going forward. On the left-hand side is just a spidergram of the sensory or the production of aroma compounds in the article that used Ansenia spora ovarum, and everything below PC1 is everything that only had Saccharomyces. So as soon as you add the non-Saccharomyces, you also change the profile of the wine, and this is something we will have to investigate further to see what a Torrellaspora or a Lasantia will do and how they interact with the bacteria, because some of them produce lactic acid, and we know lactic acid becomes toxic over a certain amount for malolactic bacteria. So this is something I think that we will see quite a bit of knowledge being generated in the next few years. So what can you do as a winemaker to drive your MLF? Is ensure you choose your yeast strain to complement MLF. Choose your scenario, co versus sequential. Think about the aroma potential. Decide on which strain of lactic acid bacteria do you want to use. What is the end goal of your wine? And if you have the opportunity to adjust certain parameters to complement MLF and the aroma potential, I think it's something that you can experiment with. So the big question is, what is your need? And that is something you have to define. Is it just the speed of MLF that you want to stabilize your wines as quickly as possible? Is it about the contribution to aroma? Do you want to use your natural diversity, which contains much more bacteria than just Inococcus uni and Plantarum? And I know that's a difficult question for you as a winemaker, but I think your suppliers and the people in the field have excellent knowledge to guide you to ensure you produce the best potential wine using MLF as just another tool in your toolkit. So thank you, muchas gracias. And that is over to Alda that will handle the practical side of MLF.